For the past decade, PCI technology has served as a ubiquitous I/O interconnect solution for computing platforms. First introduced in 1992, PCI is based on a parallel bus model with initial connectivity of 32 parallel signals operating at 33 MHz. In order to scale performance with computing requirements, the industry has either increased the number of signals or increased the signal frequency. After a decade of improvements, however, the parallel PCI model is reaching its limits, making further performance enhancements expensive, less reliable, and more complex while restricting design flexibility in delivering PCI connectivity. Here we see the effects of signal skew versus clocking due to increased frequency. Increasing the number of signals further exacerbates clocking issues by augmenting the number of signals that must be synchronized with the common clock. A new alternative for I/O connectivity is required. PCI Express technology has been developed by the industry to address the needs for the next decade's computing and communications I/O requirements. Based on a serial model, clocking data at 2.5 GHz via two differentially signaled half-duplex lane pairs of wire, PCI Express technology addresses the fundamental issue of performance scaling by encoding clock and data into a single stream utilizing SerDes silicon. As a result, we are able to increase signaling speed significantly while dramatically reducing the number of signals. The resulting reduction in pin count increases design flexibility while creating more efficient and cost-effective I/O solutions. PCI Express technology was designed to utilize the extensive industry investment in software development by featuring backward software compatibility with legacy PCI infrastructure. PCI Express architecture will be used in a wide range of design platforms as a chip-to-chip and chip-to-adapter technology. Desktop and notebook designs will utilize PCI Express slots and connectors, along with Express card modules to deliver efficient connectivity solutions and true plug-and-play capability. These benefits are offered while simultaneously enabling an enhanced graphics performance roadmap and the transition to Gigabit Ethernet. By scaling the number or width of links, PCI Express technology can scale performance to enterprise requirements. The PCI Express specification enables multiple link widths, or presumably up to 80 gigabits per second of link performance at a 2.5 gigabit per second signaling rate, and can be further enhanced through signaling rate increases. Scaling width and frequency within a serial infrastructure does not have the same limitations as discussed in a parallel model due to each signal containing encoded clock and data. Servers are expected to utilize PCI Express technology via slots, server modules, and motherboard implementations. Next-generation modules and motherboard configurations deliver new flexibility in server motherboard design, aiding in delivery of dense rack mount and blade servers. By matching the performance requirements of 10 gigabit per second interconnects, PCI Express technology enables balanced server platforms, freeing processing power from traditional I/O bottlenecks. PCI Express technology also extends PCI's role in the communications industry. Within an internet infrastructure, PCI Express technology will be found embedded in traditional communications applications as well as extended into new interconnect uses. Initial PCI Express implementations will transition PCI-based connections to the higher performance and lower pin count offered by PCI Express designs. The industry is moving forward to PCI Express solution delivery in 2004.
Hey guys, how's it going? Here from HA Utilities.
Hey, it's me, Ramit.
Alright, so today we're going to be talking about PCI and what it is.
Yep, PCI is effectively how you would connect most items to the motherboard which are not actually part of the motherboard, nor are they normally vital. For example, a Wi-Fi card is not vital, but it is preferable. Same as graphics cards or even sound cards if you're insane.
Yeah, I think the main port of PCIe is for expansion. You know, you put things into there which you want to add to your system. So PCI pretty much has 3 versions. You have the 1-link rate, you have the 2-link rate, and you have the 12-link rate. Now, I'm pretty sure anyone can tell you that the 12-link rate is much, much better. This is because there's 12 lanes, and what that effectively means is that there's 12 more lanes where data can be transferred. So there's 12 more cycles that you can do compared to the 1-link rate where only one thing can happen at a time, so receiving and sending.
PCI, PCIe, depends on which one. I'm pretty sure, if I'm wrong, correct me on this. PCI is normal, whereas PCIe is express, isn't it?
Yes,
So,
yes.
yeah, that means that effectively PCIe is smaller, more compact, and better for smaller motherboards, and it also limits the things you can add to it. So, for example, you're not really going to want to put a graphics card that's 4 gigs dedicated on a PCIe port because you won't be able to optimize the graphics card properly.
Not necessarily. All PCI ports are the same. It's the device itself that is PCI Express. So, for example, the connector is always 12 lane, but the device could be PCI, or normally graphics cards are PCIe.
Yeah, and the thing is, another problem with PCIe is, well, they are limited. Now, I know that older motherboards are much less limited in their PCIe requirements and such, but problems with those would be they aren't able to sustain large amounts of RAM and such. So, really, if you want more PCIe, you're gonna have to trade something else off. Unless, of course, you want to get a really large motherboard.
There are many things you can actually do with PCI.
Indeed, yeah. The limits are potentially it's limitless, really. Mainly because, yes,
Continue.
I think my basic logic has gone. I really shouldn't have accepted that eclair from that person during concert. Yep.
Better cut
Shut up.
some of this out. So,
Uh,
go.
yeah, PCIe, fantastic things, quite limited, but, and I'm pretty sure this is fine, they can be quite helpful for people who record videos. For example, us.
Yeah.
Can you think of any
Yeah. There's something called the NVIDIA SLI. Crossfire for you ATI idiots out there. Effectively, what it allows you to do is link 2 graphics cards together. What this allows you to do is it pretty much allows you to harness the full potential of your graphics cards, allowing you to make it more efficient when using your PC. Something that laptop users know nothing about because they don't have any PCI ports.
There are some which do, but the PCI ports are tiny. Well, they're more likely A to be PCIe, and secondly, well, they're just not very useful on a laptop. And anyway, if you want a proper future-proof laptop, then you just get a really powerful one.
The thing with PCI is that it's backwards compatible. So say you have a one-way PCI card that can fit in a 12-way port. So no matter what, as long as you have a large connector, you're always going to be able to fit your devices as
Indeed,
the
yeah.
right amount.
Yeah, so, for the example, we're going to take my uncle's old computer. Again. No, oh god, this time that's nice. Now, his computer had 4 PCI ports, but the thing is, they were 1-lane PCI ports. There might have been 4 of them, but really, they're terrible. And, well, that's the problem with older ones. You can't, well, have... So, for example, if you have something optimized for 12 port, you're not going to get enough from lower port.
Yeah, so effectively all you guys really need to know is that PCI is good It's fast. It makes your computer more efficient, and if you have the right stuff, it can make your computer more powerful.
And not just more powerful, you can make it more useful.
Yeah. That's pretty much it for this episode, guys. If you have any questions about PCI or have anything for us to answer, drop down in the comments. Guys, like us on Facebook, follow us on Twitter, and I'll catch you later. Peace.
Goodbye.
See you guys.
ISA card, VGA graphics. The question, of course, is, does it work? Well, there's only one way to find out. But before we do that, here's a close-up. Alright, it's installed in the trusty 386. Dip switches are set according to the manual. All that remains now is to connect it to a monitor and power and a keyboard and fire it up. And let's hope that fire is not the operative word. Alright, we're all hooked up and ready to go. I'm not going to yell smoke test, but if you want to, feel free. So here we go. Success! Let's see if we can run a test or two on it. Maybe not. I thought PC Probe was on this machine, but it is obviously not. Sierra? What have we got? King's Quest 1. Whoops. Try that instead. Oh. Or maybe not. Oh, well, that one's got something in it. Let's try that. And what is it that starts it? Isn't it Sierra, usually? Yeah, I don't have a sound card in this machine. That. IBM. Compatible joystick. No. No mouse. Now let's try it again. And there we go. Oh yeah. The old copy protection. Where the manual for this game is, I have no idea. But we can see that the colors do work. Yeah, sure. Where's my super slash? I can't find my super slash. Oh, there it is. Tell you what, let's put PC Probe on this and try again. Here are the results of the extended video benchmark in PC Probe. It took far too long to let it go on camera, but I will do the simple benchmark from PC Probe on camera. We'll do that in just a moment. Alright, that was the extended video benchmark. Now let's do the simple video benchmark. There we go, 917.01 characters per millisecond. What a speed demon. Well, let's see the system speed test. There we go. And the beeping is in no way annoying. And there we have it, the Paradise Basic VGA card. A good way to work on your 8-bit computers using an LCD monitor in these days when the CGA and EGA monitors are becoming very hard to come by in operating condition. Thanks for watching the video, and see you next time.